Welcome to Spring LIB.
Before getting into solving this problem, it is very important to define directions. So let's say that rotation in the clockwise direction will be positive, and rotation in the counterclockwise direction will be negative. Okay, so now let's begin solving the problem. We have these two vectors of force acting on this rod, and we know that the rod, we want to calculate the torque about this part, this origin. So let's begin with this one. Force 1. Force 1 is going to exert torque 1, and that is going to be equal to the force times its distance from the center of rotation. So that'll be 8 newtons times 2 plus 5 meters. So that is 5 meters. So we have 40 newtons times meter. Now let's talk about torque number 2. Well, that one is acting in the opposite direction. So that means that it will result in counterclockwise rotation. So we'll have negative force 2 times distance of force 2 to the center of rotation times sine of the angle. Because the only component that results in rotation is the vertical component. This other component is simply pushing the rod to the left. It is not rotating it. So that is why we only account for the opposite component of force. Over here, we didn't have to do that because 100% of the force was on the vertical axis. But over here, we have 30 degrees. So we have to write negative 12 newtons times 2 meters times sine of 30 degrees. And it turns out that sine of 30 is 0.5. So 0.5 times 2 is 1. So we simply have negative 12 newtons times meters. Now it is a coincidence that 12 newtons times meters is the same as the magnitude of the vector. In all cases, you should always take into account if you have an angle. Now let's find the net torque. Well, the net torque will be the sum of these torques. So that is 40 minus 12, which is 28 newtons times meters. And remember that this is positive, so that is clockwise. And that is our final answer.